Hello everyone and welcome to Kiru's online lectures. I am Kiraj Jamtani and today's topic is Alcohols, Phenols and Ethers Part 1. So in this video we will be studying introduction, classification, nomenclature and structure of these functional groups. So now moving on to the introduction part. So first of all we'll study what are alcohols. Like as we know, alkanes, that is CnH2n plus 2, the general formula of alkane. So from alkane, if hydrogen is removed and in place of hydrogen we add OH group, so that is known as alcohols. Like we have methane, we will remove one hydrogen, that is we will substitute hydrogen by OH group, so this is known as methanol. Similarly, if arenes, that is benzenes, if their hydrogen is substituted by OH group, then it is known as phenols. Like we have this benzene, so benzene hydrogen substituted by OH group, thus we will get over here phenol. Now the next is ethers. We have alkane, so alkane hydrogen if now substituted by alkoxy group, so we get ether. For example, we have CH4, here hydrogen is replaced by alkoxy group, we will get CH3OR dash, this is known as ether. Coming on to the classification part, alcohols and phenols, they may be classified as mono, di, tri or polyhedric compounds depending on whether they contain 1, 2, 3 or many hydroxyl groups respectively. Like if they have one hydroxy group, so it is known as monohydric. This is for alcohols. Same is the case with phenols. If one hydroxy group is there, this is known as monohydric alcohol and phenol. But if two hydroxy group is there, like CH2OH and benzene 1,2-diol, so this is known as dihydric alcohols and phenols. Similarly, if we have three hydroxy groups, CH2OH, CHOH, CH2OH, and in benzene OH, OH and OH. So if three hydroxy groups are there, we call it as trihydroxy alcohols. Coming on to the classification of monohydric alcohol. Monohydric alcohol can be further classified according to the hybridization. Now if they are having sp3 hybridization, so sp3 hybridization is shown by primary alcohols, secondary alcohol, tertiary alcohol, allylic alcohols and benzylic alcohols. Primary alcohol, primary alcohol is the alcohol over where the hydroxy group is attached to the primary carbon. When hydroxy group is attached to the secondary carbon, we call it as secondary alcohol, and when hydroxy group is attached to the tertiary carbon, we call it as tertiary alcohol. Allylic, in this the OH group is attached to the carbon next to carbon-carbon double bond, like CH2 double bond CH, CH2OH. So OH group when attached to the carbon next to the carbon having double bond. Benzylic group, so benzylic group, here OH group is attached to the sp3 hybridized carbon atom which is next to the aromatic ring. So this next to the aromatic ring CH2 and OH is attached to this carbon. So all these are the examples of sp3 hybridization. Next, sp2 hybridization. In sp2, these alcohols contain OH group bonded to a carbon-carbon double bond, that is to a vinylic carbon or to an aryl carbon. So here first we have vinylic alcohol. Vinylic alcohol is an alcohol in which OH group is attached to the double bonded carbon. So CH2 double bond CHOH. Second is phenols over here. So phenols comes under the category of sp2 hybridization. Now moving on to the classification of ethers. Ethers are classified as simple or symmetric if alkyl or aryl group attached to the oxygen atom are same, and they are known as mixed or unsymmetrical if two groups are different. For example, if we have CH3OCH3, so this is simple or symmetric, but if we have CH3OC2H5, this is mixed or we can call it as unsymmetric. Moving on to the nomenclature of alcohols. So the common name of alcohol is basically derived from the common name of alkyl group and then adding the word alcohol to it. For example, we have CH3OH. So this alkyl, it is methyl and alcohol word will be added, methyl alcohol. But if IUPAC name, so according to IUPAC name of the alcohol is derived from the name of alkane from which alcohol is derived. Like over here, E is substituted by all. So it is methane. The alkane, one carbon is methane, one carbon OH group is attached, so therefore it will be known as methanol. Similarly, if we have CH3CH2OH, so the common name will be ethyl alcohol and IUPAC will be ethanol. But if we have CH3CHOH, CH3CHOH, according to common naming, it is isopropyl, so it will be known as isopropyl alcohol, and the IUPAC name is 2-propane 2-ol. Similarly, if we have CH3C, CH3CH3OH, now this is tertiary butyl, so we'll call it as tertiary butyl alcohol, and IUPAC में we'll select the longest chain, so here we'll write 2-methyl propane 2-ol. So this is how the nomenclature of alcohols is done. Moving on to the nomenclature of phenols. So in phenols, like we have the first example, this is in benzene ring, if one OH group is attached, so its common name and IUPAC name is same, that is phenol only. But if in benzene ring two OH groups are attached, so its common name becomes catechol and the IUPAC name is benzene 1,2-diol. If in benzene ring 3 OH groups are attached, OH groups attached but in para position, so this is known as resorcinol and its IUPAC name is benzene 1,3-diol. Similarly, if in para position 2 OH groups are attached, so there that is known as quinol and its IUPAC becomes benzene 1,4-diol. Now if we have OH group and in ortho position we have methyl, so its common name is orthocresol and its IUPAC name becomes 2-methyl phenol. Similarly, if in para position methyl group is attached, so it is known as paracresol and its IUPAC name becomes 4-methyl phenol. Similarly, if in meta position CH3 group is attached, metacresol, IUPAC name becomes 3-methyl phenol. Now moving on to the nomenclature of ethers. So ethers, the common name of ethers are derived from the name of alkyl or aryl group which is attached to it, and in IUPAC name alkoxy alkane, alkoxy, this is the prefix which is added to it, and alkane the suffix selecting the longest carbon chain. According to that only its naming is done. For example, we have CH3OCH3. So common name will be dimethyl, because 2 methyl groups are there, dimethyl ether. But according to IUPAC name, the smallest carbon will go with the O. So its name will be Methoxy Methane. If we have CH3, CH2OCH3, so here it will be ethyl methyl ether. So ethyl methyl, why will write E? In alphabetic order E comes before, so ethyl methyl ether, and IUPAC name will be methoxy ethane. Like we have CH3O, CH, CH3, CH3. Now this is what? Isopropyl. This is methyl group. So we'll write methyl isopropyl ether, and IUPAC name will select longest carbon chain 1, 2, 3. In 2 there is methoxy. So 2-methoxy propane. So this is how nomenclature of ethers is done. Now moving on to the structure of these functional groups, that is the structure of alcohols. In alcohols basically we will discuss the structure of methanol, then phenols, and then ethers structure. So drawing the structure of methanol, we have CH3OH, here CH, H, and CH3 is like this, O and H. So the angle between this is 108.9 degree, and the length of this OH bond is 96 picometer, and CO bond length is 142 picometer. Thus in alcohols, this oxygen of OH group is attached to the carbon by sigma bond, and yes, which is formed by the overlapping of sp3 hybridized orbital of carbon. And here bond angle, as we can see over here, this bond angle COH is slightly less than the tetrahedral angle. And why it is so? It is because due to the repulsion between unshared, here there are unshared pair of electrons. It is because due to the repulsion between unshared electron pairs of oxygen. Because of this only this bond angle is slightly less than that of tetrahedral. Moving on to the structure of phenols. So like this, we have phenol benzene ring. Here in benzene ring there is OH group attached to it, having two electron pairs, that is unshared electrons. Here OH group is attached. This OH group is attached to this carbon, which is sp2 hybridized carbon of an aromatic ring, and here the carbon oxygen bond length is 136 picometer. The carbon oxygen bond length is 136 picometer in phenols, which is slightly less than that of methanol as we saw earlier. Now again it is due to the partial double bond character because of conjugation of unshared electron pair of oxygen with aromatic ring. This is the first reason. Second, due to sp2 hybridized state of carbon to which this oxygen is attached. and the bond angle over here is 109 degree. Now moving on to the structure of ethers. Ethers में especially we'll talk about methoxy methane. So methoxy, which is CH3 O CH3. Again it has two lone pair of electrons and the bond length between CO is 141 and angle between them is 111.7 degree. In ethers, as we can see over here, the 4 electron pairs, that is the 2 bond pairs and 2 lone pairs of electrons on oxygen, are arranged approximately in a tetrahedral arrangement only, and this bond angle is slightly greater than the tetrahedral. It is due to the repulsive interaction between two these bulky groups. CO bond length is 141 picometer, which is almost same as in alcohols. So in today's video we studied about the introduction, classification, nomenclature and structure of alcohols, phenols and ethers. Hope you guys are finding my videos helpful. So do like, share and subscribe the channel. Thank you.